Hello GVA students, welcome back. My name is Mr. Thompson and I am your guest video teacher this week. We'll be going through lesson 14 in the Ready textbook. Today we're doing session 1. It's page 277 through 280, and we're going to be talking about using the 4 operations, all 4 of them together, with positive and negative rational numbers. So this is the week it all kind of comes together. So we'll start off like we always do with a little brain bender. So over here we have our 2 lines, we have our 4 letters, and we have our 4 equations. This is going to be a same and different. Take a look and see what's the same and what's different about these 4. The first one, we have positive 1.5 plus 3. For box B, we have 3 minus 1.5. Box C, negative 1.5 plus 3. And over in box D, we have negative 1.5 minus 3. So, take a few minutes, think about what's the same, what's different. And we'll talk about it in just a second. Okay, welcome back. So, what'd you come up with? Here's a few that I noticed. Of course, notice that all the terms that we use are 1.5 or 3, or the opposite of those numbers. Notice that A has the greatest value. If A has the greatest value with both of those positive rationals, then the opposite of those, the negative rationals on D, would give you the least value, right? And what about the values of B and C? Did you notice those were the same? Yep. Because addition is commutative, right? And B and C actually give you the same answer. And of course, B is the only expression in those 4 where 3 is the first term. Not that difficult, just a little something to get your brain moving. So let's move on and look at session 1 on page 277. Okay, here's our sample problem. Let's work through that together and see what we have. Nota lives in Minnesota. He records the lowest temperature each day for 1 week. What is the mean? Ooh, the mean. You remember that from last year, right? What is the mean of the temperatures? And the temperatures each day were negative 7.3, negative 11.2, positive 2.2, 0 degrees, negative 1.7 degrees, positive 3.3 degrees, and 0 degrees again. Minnesota is a cold place. So what's the mean of the temperatures? Do you remember how to find the mean? Last year we talked about statistical variation. We talked about mean, median, mode, range, all that, remember? Well, the mean is like the average, right? So to find the average of numbers, you add them all together, and then you divide by the total number of data points that you added. At negative 7.3, negative 11.2, positive 2.2, 0, negative 1.7, positive 3.3, and another 0. Now notice what I've done here. I've grouped these up, and I've grouped them into all the negatives, all the positives, and all the zeros. So that just makes it a little easier to add everything together. So let's work through our negatives first. 7 and 3 and 2 is 12. Bring down our decimal. 7 and 1 and 1 and 1 is 10. And 1 and 1 is 2. And of course those are all negatives we're adding together, so it stays negative. That's a negative 20.2 on the negative sides. Now, positive 2, positive 3 is positive 5. Another positive 2, positive 3 is positive 5. And of course 0 and 0 is 0. So let's take that positive number, subtract it from our negative number, and see what we get from that. So we'll take that 5.5 and move it over here. So let's see, take that down to 1, take that down to 10, down to 9, bring it over there. So 12 minus 5 is 7. 9 minus 5 is 4. What we have left is 1. And that's on the negative side, so we have negative 14.7. And of course we have the 0 over here, nothing happens with that. So negative 14.7 is what happens when you add all of those numbers together. So we have negative 14.7, that's fine. Now we're dividing that by how many pieces? We're dividing it by, what do we got? 1, 2, 3, 4, 5, 6, 7. We had 7 data points altogether. So we're dividing negative 14.7 divided by 7. And if you do that, negative 14.7 divided by a positive 7, you know the answer is going to be a negative, so we can keep our negative right there. 7 goes into 14 twice, and 7 goes into 7 once. So what we get as an answer is negative 2.1. Negative 2.1 what? 2.1 degrees, right? We're talking about temperature. So, if we go back up here, right, what we've done is we've just added all of these together. And then we've divided by the total number of terms, right, one for each day. So that's all those temperatures divided by 7 days. And that gives us an answer of negative 2.1 degrees Fahrenheit average temperature. All right, a little bit of a reminder for finding the mean, right? So much for page 277. Let's move forward. Page 278. And of course, we start off with a connect it, draw our connections. What is the mean of the temperatures? We saw what that was. That was negative 2.1 degrees. And the second part of that, explain how you know. So, how do we know? Well, we know because the mean is the sum of the temperatures divided by, because the mean is the sum of the temperatures divided by the number of temperatures. And that's how we know. So that seems like a rational explanation we could put down for that. So question 2 looks ahead. And look ahead says you can find the mean by writing and simplifying an expression with rational numbers. When you solve a problem involving rational numbers, it can sometimes be hard to get a sense of how large or small the solution should be, or even whether it should be positive or negative. Now, starting by approximating the solution can help you understand the problem and decide whether your solution is reasonable. So we're talking about estimation here. A, underneath number 2, it says, one way you can approximate the sum, negative 24 3/4 plus 15 1/4, is by rounding each fraction to the nearest integer. So what is the approximate value of negative 24 3/4 plus 15 1/4 if you round to the nearest integer? Well, that's pretty simple, isn't it? Let's take a look at that. Negative 24 3/4 rounded to the nearest integer. Well, 24 3/4 is almost negative 25. So we'll call that negative 25. And 15 1/4 is a little bit more than 15. We'll round it down. We'll call it 15. Now I got negative 25 plus 15. Hey, that's pretty easy, right? If you have negative 25 plus 15, that's like 25 minus 15. That's just 10. And it's a negative number, so we have it as a negative 10. That's our approximate value. Imani says negative 24 3/4 plus 15 1/4 is equal to negative 40. Is her statement reasonable? And explain why or why not. Well, is her statement reasonable? Well, no, of course not, because, I mean, we estimated and came up with negative 10, so negative 40 is way out there. So that's not reasonable. Is her statement reasonable? No, it is not. So explain why or why not. Well, why on earth could she have gotten that? And if you look at what she might have done, you can see what it is. She actually did negative 24 3/4, and she subtracted 15 1/4. She was thinking that it's negative 24 3/4, and then you take away another 15 1/4. Now that would be negative 40, but that's not what you do. So we know how she got it wrong. A quick way to see that she got it wrong is just by estimating. Explain why or why not? Well, we can say that the approximate answer is negative 10. So negative 40 makes no sense. Well, not if she read the problem correctly. So that's a good way to think about that. Let's look at question C. Approximate the value of negative 28.3 times negative 47.9 by rounding each factor to the nearest 10. So we're rounding to the nearest 10, right? So how do we round to the nearest 10? Well, we have to go look at our tens place, right? Our tens place for both of those is right there, right? Because this is the ones place, that's the tens place. If you go in the other direction, that's the tenths place, right? So if we're rounding to the nearest 10, negative 28.3, well, 28.3 is really close to negative 30. So we can call that negative 30. So that's negative 30. And we're multiplying that by negative 47.9. If you round that to the tenths place, that's really close to negative 50. So if we're going to multiply that out, we know that we're multiplying a negative times a negative. That means our answer has to be a positive. So we'll just put our positive down there. And so what's 30 times 50? Well, 3 times 5 is 15. And that's both in the tens place. So we have 3 times 5 is 15, and we have those two trailing zeros you put on there. So negative 30 times negative 50 is positive 1,500. So that is our estimation, right? It's not the actual answer, it's our estimated answer for that. It's 1,500. So Eric, down here in question D, calculates negative 28.3 times negative 47.9. He gets 1,355.57. Is that reasonable? And explain. Well, yeah, it is. It's pretty reasonable. And why would that be reasonable? Because, let's say, because Eric's answer is close to the estimate of 1,500. So, yeah. So, if it's 1,500 is the estimate and he's, 1,355, that's within 150 or so. So that's good. That's close. We can deal with that. Do we know if he's actually right or not? Not without working it out, but we know that the answer is reasonable. Even if it's not correct, it's reasonable. It makes sense. I mean, it is correct, but, So why is it useful to approximate the solution to a problem involving irrational numbers? Why is it useful? Why would you want to go through that extra step of rounding and then doing the work twice? You do the work once to see kind of where you are, then you do it again. What's the purpose of that? Why not just work it out once? Well, it gives you an idea of where you're going, right? It's always easier to go someplace if you have an idea of where you're going first. So if you approximate the answer, it'll give you a sense of the size of where you're going. I can help you decide if your answer is right, or if you've done something wrong, have to go back and try another solution strategy. So we can say it gives you a sense of the exact answer, and can tell you if you're on the right track. Sounds pretty good. So that's page 278. Let's look forward to page 279 and see what we have here. We have my favorite thing in the world, a graphic organizer. Yay! This one is about rounding. As you can tell, rounding is a big thing that we're going to be looking at today. So let's take a look and answer some of these questions. First of all, what is it? In your own words, what would you say rounding a number would be? I like that one. We could try that. We could say that it's approximation, right? Good word. You're approximating a value. You're approximating that value by, how would you phrase it? By finding the nearest given place value. Yeah. And that value could be tens, hundreds, other stuff like that. So, good. So, what do we know about it? Well, the one thing that we just learned from the previous page is that it makes calculations a lot easier, right? You don't have to get into all the details of all the little number values. If you can just kind of ballpark it and find out round about where you're going to be. So, round values make calculations easier. Pretty good. So, some examples. Let's look at some examples of rounding. So if we had, let's say, 11, and round that to the nearest 10, 11 rounded to the nearest 10 would be 10, right? Let's see, we have 104.5. Let's round that to the nearest integer. So we're taking 104.5, rounding it to the nearest whole number. And you know the rules for that, right? If it's 1/2 or above, it rounds up. If it's less than half, it rounds down. So 104.5 is right at 1/2. And so since it's right at 1/2, we take it up. So that would round to 105. Looks like that. Let's take 237. 237 and round that to the nearest 100. So it's 237 rounded to the nearest 100. Well, it would have to be 250 or more to round up, right? But since it's not 250, it would have to round down 200. And let's take 78.68 and round that to the nearest tenth. Not the nearest 10, the nearest tenth. So it's on the other side of the decimal. So the tenths place is the 6. So that would round up to 78.7. So those are some examples. So some non-examples. We'll do those in red to show that they're not examples. Let's see, 458 to the nearest 10. And if you said that was 500, does 458 round up to 500? Well, yeah, it does. So why is that wrong? Well, because you're rounding to the nearest 10, not the nearest 100, right? If you're rounding to the nearest 10, it would be 460. So it's kind of important when you're rounding, know what place number you're rounding to, because if you're rounding to the wrong place number, you'll be way off. Because 460 is way off of 500. So we know that one's not right. And 5.62, we'll do 5.62, and we'll round that to the nearest tenth. And if we said that was 5.7, well, 5.7 is the nearest tenth, but look at the hundredths place, right? The hundredths place is a 2. So 5.62 rounded to the nearest tenth, I'd have to round down to 5.6. So if we rounded it up to 5.7, that's too great a leap, right? It's further away from 5.7 than it is to 5.6. So there's a couple non-examples for you. Let's look at number 2. Enrique says that to round the decimal to the nearest integer, you can just ignore the decimal part. Is Enrique correct? And explain. What do you think? Is Enrique correct? Can you just drop the decimal off? Well, if you had 4.2 and you wanted to round that to the nearest whole number, to the nearest integer, Enrique says just take that 2 off and you're left with 4. Well, 4.2 rounded to the nearest integer. Okay, well, what if it was 4.8? Well, by Enrique's rules, you'd have to take that off and then you just keep 4. That doesn't work that way, does it? 4.8 rounded to the nearest integer isn't 4, it's 5. So Enrique is wrong, wrong, wrong. No, 1,000 times no. Why? Well, if you ignore the decimal part, you could round to the wrong value. Ignoring the decimal sends you to the wrong value. If, for instance, the decimal is greater than 5. Let's move on to 280. All right, now we're up in the green pages, so I want you to try these on your own. Mai is a park ranger at Death Valley National Park in California. She records the elevation relative to sea level at different points in the park. So we have elevations of negative 32.6, positive 24.7, negative 8.3, positive 19.1, and negative 8.4. What is the mean of these elevations? And show your work. Ooh, it's a lot like the sample problem we did at the beginning. Give us a shot and see what you can do. Pull out some data and tell me what your answer is. And we'll be back in just a second. Okay, welcome back. So, you know how to do this because we did it before, right? You just take all of these and add them together. So we're taking negative 32.6, we're adding 24.7, we're adding negative 8.3, we're adding 19.1, and we're adding negative 8.4. And then we take all that and we divide the whole thing by the number that we have, which is 1, 2, 3, 4, 5. So we divide the whole thing by 5, right? So let's work those two and see what we get. I'm going to do the same thing I did in the first problem, and I'm going to add the negatives together, then I'm going to add the positives together, and I'm going to combine those two. And now you could work from left to right and just say, negative 32.6 plus 24.7, then take 8.3 off of that. But as for me, I think combining the negatives and then combining the positives and doing it that way is a little bit easier. Your way could be different. That's okay. Lots of different ways to get to the same destination in math. So negative 32.6, let's take off another 8.3 and take off another 8.4. Those are our negatives. Our positives are 24.7 and 19.1. So then we'll add those together. So 6 plus 7 is 13. 8 plus 8 is 16, and 3 is 19. And 3 and 1 is 4. That's negative 49.3. Now we can add our positives. 7 plus 1 is 8. 9 plus 4 is 13. 2 and 2 is 4. Okay, so we have negative 49.3 and a positive 43.8. Now the negative 49.3 has a larger absolute value. So we'll just pull that down here. And we'll say 43.8. And we know that answer is going to be negative. And we subtract these two. So that becomes 8. That becomes 13. 13 minus 8 is 5. 8 minus 3 is 5. And 4 minus 4 is 0. So that gives us negative 5.5. We have negative 5.5. Is that our answer? No, not yet. We still have to divide, right? All we've done is we've added all of our terms together. Now we have to divide them by 5 to get what the mean is. And that's not too bad. That's just negative 5.5 divided by the 5 data points that we have. And 5 goes into 5.5 how many times? Well, 5 goes into 5 once. So, and it's a negative divided by a positive, so the answer stays negative. Negative 5.5 divided by 5 is negative 1.1, right? And our elevation is in meters, so our average elevation. You can also say the mean of the elevations. The average elevation is negative 1.1 meters. How would you do problem B here? Check your answer to the problem 3A. So if we've worked this out like this, and we want to see if you're right, so we've been doing rounding a lot today, so let's check our problem doing rounding. So if we were to take these numbers and round them all to the nearest integer and work it that way, see what we have. So we'll go down there and we'll show it this way. So rounded to the nearest integer, we have negative 32.6 becomes negative 33. Negative 20 or positive 24.7 becomes positive 25. Negative 8.3 stays down at negative 8. 19.1 stays at 19. And negative 8.4 rounds down, and it's negative 8. So those are our data points, and we know we're adding them all together, and we're dividing it all by 5. So let's work it out that way. So if we have negative 33 and negative 8 and negative 8 again, 8 and 8 is 16 and 3 is 19. 3 plus 1 is 4. It's negative 49. On our positives, we have 25 and 19. 9 and 5 is 14, and 2 and 2 is 4. So that's 49, negative 49, and 44. We'll do the same thing as we did before. We'll take that 44, pull it down here, since 49 is the largest absolute value. Subtract 49 from 44 gives you negative 5. All right. Is that close to what we got? Yeah. Because if we have our negative 5, we divide that by our 5 data points, that gives us negative 1. And negative 1 is very close to what we got using the actual numbers, negative 1.1. So that tells us that when we're checking using the rounding, our answer was reasonable, as they say. And that's a good way to check. That's page 280. So, what'd you think? Not too bad, kind of a short one today. Join us again tomorrow. We'll go with lesson number 2. And we'll continue on using all 4 of these operations with positive and negative rational numbers. Thanks for joining me, guys. I'll see you next time. Bye.